Welcome to module 2.2. It's a rather small module where we'll talk about the first few things about isolation and confinement principles, but we'll revisit that in more further details later, because this is quite important, especially when you are running multiple different services on the same server. You need to isolate the different processes or services that you are running, so that they don't contaminate each other's information. Also, nowadays we are talking about cloud based computing and virtual machines and cloud and so on. So confinement principle gets further importance because of all those. So the idea here is that we work under the paradigm that code that you are running on your system, especially on behalf of normal users, would be buggy and untrusted, and therefore if it does any kind of harm to the system, that should be contained or confined. So and also this is true in real life, because you often download apps, you download extensions, plugins and codecs for media player and so on, and you don't know who wrote this code and what their provenance is and so on. So therefore you have to be careful when running your untrusted code. Also there are applications which are exposed, like PDF viewers and outlooks, because they might actually contain some code if they have been contaminated. And also Outlook, for example, you might be sent a PDF file or a Word file with the executable code inside them and so on. There are legacy daemons in for example in Unix system, and then there are honeypots. The honeypots are actually systems that are designed to entrap attackers. And so if somebody is trying to download some bad application, malicious application on your system, the honeypot needs to basically isolate that execution of that application so that it does not harm the entire system, and then at the same time study the application, the malicious application, to understand what is going on. And most antivirus companies like Symantec and McAfee or Kaspersky, they actually deploy honeypots to collect malware and collect signatures, so that they can use that signature in their signature files or definition file, virus definition files. So the goal here is that if the application misbehaves, I want to kill it, but I also want to contain the damage it might have done before I manage to kill it. So one way to do that, of course an expensive one, which is to have a separate computer or separate hardware to run each application separately. So application 1 will run on one computer, application 2 will run on the second computer. They are totally air gapped, and chances of them intermingling is minimized. Then of course this is very expensive, because we are nowadays your cell phone itself is running many applications, so you cannot have separate hardware for each of those. So in order for managing the cost, another way to do that is to use virtual machines. So you can have one virtual machine running your mail server, one virtual machine running your web server, and there is a virtual machine monitor such as VBox or VMware and so on, that will host these various operating systems, and then you will be achieving some kind of an isolation. Now as we will see later that these are not necessarily completely isolated. There are side channels and so on that we have to be wary about, but for now let's believe that by doing this one can achieve this kind of an isolation. And then the other thing is something that is done by user mode Linux. So each process itself is sort of like it can be treated as a virtual machine instance, and the idea there is that there is a wrapper around each process, and this wrapper actually does something called system call interposition, and the idea is that whenever the process tries to do a system call, it is intercepted and some caution is taken in order for this system call to go through, and that gives quite a bit of containment in terms of if the process tries to do any harm to the system, it can be sort of contained. So this is one way of doing sandboxing, and this is pretty common nowadays to do this. So there are other techniques such as software fault isolation. So what is software fault isolation? So the idea is that if you have a software that you don't trust, so let's call it a program P, and then you have an SFI transformer. So what you do is that you input this your program to this SFI, it could be in binary, and then SFI will generate a instrumented binary P prime that would separate out some things such as if it is a multi-threaded program and threads actually do a lot of they share the same address space, of course, and they do a lot of interchange of information. So if you want to do a software fault isolation, you basically create what is called a thread local storage. So it's even within the same address space of the process, you kind of separate out certain address ranges where a certain thread can actually access or write and so on. So therefore by this you will achieve quite a bit of isolation, and these are called logical fault domains that each thread can access. So this is getting actually a lot of traction these days, and will actually have a paper that in the study material to study more about some of the software fault isolation techniques. Also in the browsers, where the most of the time we run untrusted code because we are going to various websites, there are browser architecture based access control, and these are based on the ideas that same if you're rendering a particular web page on your browser, and then you should not be actually accessing certain other websites content in it unless certain permissions are relevant and so on. So there is same origin principle, content security policy. This is sort of like a metadata that comes with the content of the web content and the web browser should be cognizant of the content security policy and then accordingly enforce it. Cross origin resource sharing, and this is basically to share certain resources in various iframes and so on, and then confinement of with original web level, which is actually where the web content is labeled for various security control, and this is a mandatory access control based. Now we will have very detailed lectures in the future in this class, where we will have browser security as well as web server security, and we will look into all these issues later. So just to make you aware that this confinement principle is very important in the browser, and there are various standards or rather being talked about right now to be standardized by the W3 consortium, but this is very important, and we will have a lot more detailed about this in the near future. So one of the way to implement confinement, especially the ones that we saw like where you have the system call interposition, is using what is called a reference monitor. So reference monitor mediates request from applications to access certain resources or to make system call, and so it implements protection policies and also ensures isolation and confinement, and it must be invoked every time a sensitive resource is being referenced or a sensitive system call is being made. It should be tamper proof, so that reference monitor should not be tampered to not monitor certain system calls, or it should not be somebody should not be able to kill it, and even if it gets killed, then the monitored process must be killed as well, so that no harm can be done without being monitored. And it should be small enough, the implementation of this reference monitor should be small enough, so that you can analyze and validate that this itself is not harmful, right. So, this is important. So, that is our first superficial introduction to a confinement principle and isolation. We will go into much more detail about this topic after the next module. The next module is about Unix user IDs and IDs of Unix processes, because they are the mainstay in Unix for controlling privilege and enforcing what is called the principle of least privilege, which allows us to confine or contain the harm done by a program when it is behaving maliciously.